Everybody done with these three? Okay. Abby, tell me how many zeros here?
4.
Good. Isabel, even or odd? Good. Ashton, positive or negative leading coefficient? Good. Alan, how many zeros?
1.
Libby, even or odd?
Odd.
Very good. Jana, leading coefficient? Very good. Caleb with a C, how many zeros?
1.
Felix, odd or even? And Jenna, leading coefficient. Very good. So everybody's good with those. Any questions? Alright, now the fun stuff. It says graphing polynomials, but let me explain. It's not really graphing because it's not going to be perfect. It's sketching. So your graph might look different than everybody else's, and mine might even look different than yours, but we should all have the same zeros. So same x-intercept, same in behavior. Okay, that's all I'm going to be looking for. So the first step to graphing polynomials, you find the zeros, of course, and list their multiplicity. The reason we have to do that is because even multiplicities like 2, 4, 6 are going to kiss the x-axis. Okay, so y'all should not know anything about kissing because y'all are too young, but I'm sure you've seen people kiss. When they kiss, their faces meet and then separate, correct? They bounce off each other. Their faces cannot go through each other. Not in this world anyways. So that's what even multiplicities do, or zeros with even multiplicities. So draw 2 zeros, and I'll show you an example. If your x-intercept has a multiplicity of 2, 4, 6, it's going to touch the x-axis. This pen's not working. But it's not going to break through the x-axis. It's going to bounce off of it. Like that. Again, it's going to touch it, but it's going to bounce off of it instead of going through the x-axis. So you can put kiss / bounce. That's what an even multiplicity does. Now an odd breaks through. So if it has a multiplicity of 1, 3, 5, when it touches the x-axis, so here's another example, it's going to break through the x-axis. Same thing here, break through it. And then just so you won't have to keep flipping back if you forget the end behavior, we're going to list it again right here. After you find the zeros and multiplicities, you find if it's odd or even, and positive or negative coefficient, so you can draw the end of your graph. So if it's odd with a positive, it's going to go which way?
Down.
Good. If it's odd but negative, it's going to go what? And then if it's even negative, sorry, I kind of changed directions. If it's even negative, it's going to go down, down. But if it's even positive, up, up. Alright, now we can start graphing. So first thing, find the zeros. First step. These are already in factored form, so what are my zeros? Very good. Next we find their multiplicities. These all have a multiplicity of what? Very good. Which means all of these are going to what? The x-axis. Break through. Good. What's our degree? How'd you get that? Good. So if it's 3, this is what kind of function? Good. Alright, do y'all remember how to find out if it's positive or negative leading coefficient when it's in factored form? They're all being multiplied together, so you just multiply the coefficients of x together. Not necessarily the number, but we just care if it's what? Positive or negative. So this one?
Positive.
So 3 positives multiplied together would make a what? Positive leading coefficient. So what's going to be my end behavior?
Down.
Down, up. Very good. That's all we need to graph. Sketch, excuse me. First thing, go ahead and draw your zeros on your x-axis. And then draw your end behavior. So your end behavior has to be on the outside of your zeros, because obviously it's not going to be on the inside. It can't come back in. On the left side, it's going to be going down, so that's where I'm going to draw my arrow. On the right side, it's going to be going up. You can see now why it's called sketching. It's not going to be perfect. When I get to this 0, am I going to bounce off of it or break through it?
Break through.
Good. On all of them, correct?
Mhm.
So make sure it's just smooth and continuous. That's what polynomials are. Some people in my last class were drawing their polynomials like this. Don't do this. Polynomials don't have like sharp points. They're smooth and continuous, okay? So make sure they're not clean. Also, like when you get to where it's going to bounce off, don't go like, because this is not a function, right? It doesn't pass the vertical line test. Does that make sense?
Mm-hmm.
Okay. Next one. Are any questions about this before we move on? All right, what are my zeros?
-3 and +3.
Good. What is my multiplicity for this one?
3,
And this one?
2, 3, 5.
So before we move on, just remember that this is going to break through the x-axis. This one's going to hit it and bounce back. What's the degree?
5.
So it's
Odd.
odd. Positive or negative leading coefficient?
Positive.
What's the end behavior then?
Down.
Good. You might have questions about that. Let's graph it. Alright, so at -3 has a odd multiplicity. That's why it breaks through. But on 1, that's where it has an even multiplicity of 2, so it's going to hit it and bounce back. Y'all have any questions so far? Alright, do number 10 on your own. Again, they probably won't look the same, but make sure you have the same zeros and in behavior. Alright, let's go over this. Meredith, tell me my 3 zeros. Alright, does everybody see how we got those? Some of y'all didn't have the x equals 0 part. Do we know where we got that from?
Yes.
Okay. Abby, tell me the multiplicities of each one. Very good. Alright, the degree we know is what? So it's, okay, the leading coefficient is where y'all are messing up. The reason we have to look at all of these, not just this one. In this case, if you looked at this one, you probably got it right. But we can't just look at this, because all of this is being what? Multiplied, okay? So if we're multiplying all these x's together, we'll get 1 to x to the 4th, right? And their coefficients will be these coefficients multiplied together. So this coefficient is what? Negative. This one? This one? So a negative times a positive times a positive? Negative. Good. Leading coefficient's negative. So what's the end behavior? Yes. Everyone understand that? I think the rest of it you got. So I'm just going to graph this. Or actually, what I'm going to do is I'm going to let y'all move my pencil. When I approach the x-intercept, tell me to break through or to bounce off of it, okay? Good. Questions? Flip it. These are different because they are in what form? Standard. Good. So we need to factor it by taking out what here? Yep, x cubed, what goes in the middle? Alright, can we factor this quadratic right here? Into what?
X minus 4.
And?
X plus 2.
Very good. Now you can see it's in factored form. What is one of my zeros? And very good. Multiplicity here, which means it'll do what? Yes, this one? 1, so it'll break through. This one? So it'll break through. What kind of function, even or odd? Good, because the degree is what? Good. This one. Okay, with this leading coefficient, do I have to look at all of them? No, because these are not being multiplied together. So you look at the lead one, and is it positive or negative? Positive. Does everybody see the difference? When it's in factored form, you have to look at all of them, the coefficients of everything. When it's in standard form, you just look at the leading coefficient. Alright, in behavior then? Very good. Go ahead and start drawing. I'm going to do the same. Alright, as you're drawing it, do I break through or bounce right here? Right here? And right here. Very good. You are doing 12 and 13 on your own. Feel free to ask somebody around you for help or ask me for help.